Hello and welcome to 2-5. Today we're talking about addition equations. And our goal is that you will be able to solve whole number addition equations. Now today's topic is not hard. But what I'm really looking for is how you're showing your work. Okay, you've probably seen these kinds of questions, not quite this difficult, but starting in kindergarten, where you say 5 plus what equals 8, and you have to figure out what goes in there. Now, I know you can get to these answers, but I'm going to really be watching how you show your work. So I wanted to start off by showing this balance. Okay, if we look at this balance, you can see on one side is h plus 14, and on the other side is 82. And remember that this part in the middle is our equal sign. Okay, so we want to find the value of h, and in order to do that, you have to get h all by itself on one side and figure out what it's going to be equal to. Okay, so that's our goal. Right now, we have this plus 14 bothering the h. We need to get rid of it. So how do I get rid of a plus 14? And we can also think of it as like a positive 14. How I get rid of it is I take it away or I subtract 14. But if I take away 14 from one side, now the sides aren't balanced anymore. You can see this 82 is much heavier than this one because I took away 14 from one side. So in order to balance out those sides again, I need to subtract 14 from both sides so that the balance is equal. And if I subtract 14 from the right-hand side of the equal side, I will get 68. So h is equal to 68. Now what that would look like if I'm showing my work is I would start out with h plus 14 equals 82. And then I would subtract 14 from both sides. And then I would say h is equal to, then I subtract that, I would get 68. Okay? So that's how the work is showed. And we'll talk about our first vocabulary word for this video, and only one, and that is inverse operations. So here we go. Inverse operations are operations that undo each other. So for example, if I'm adding, if I see adding in my equation, then I know the inverse operation is subtracting. The inverse operation of subtracting, therefore, is adding. The inverse operation for division is multiplying, and the inverse operation for multiplying is division. They are operations that undo each other. Okay, so let's try a couple problems here. And really, you guys, today we're looking at addition equations. Tomorrow we're going to look at subtraction equations. And then we'll go through multiplying, and then we'll go through dividing. So this curriculum really breaks up each step along the way. So once we can get the hang of addition, then subtraction will become much easier. The multiplication and divisions will both come much easier. So let's get into addition. Alright, so our directions say, solve each equation and check your answers. Now, if it says check your answers, then you need to make sure you follow that. A lot of times kids get a little lazy and they say, oh, I don't really need to check my answers, it's just an unnecessary extra step. But really, that's the way you can know if you got it right or not. You know, there's no guessing. If you check your answer, then you say, yeah, I know I got it right because I checked my answer. Now let me explain to you why that is. So here I have x plus 62, and remember this is like our balance line, and 90 equals 93. So if I want to get x by itself, that's what I need to do. I need to get x equals something. So this plus 62 is really bothering the x. So I need to subtract 62 from each side. Now, 62 minus 62 is going to give me a 0, right? So that cancels itself out. And so I'm going to bring down my x equals, and then I need to solve this. 3 minus 2 is 1. 9 minus 6 is 3. So x is equal to 31. Now to check my answers is I'm going to solve x plus 62 equals 93 for x equals 31. Okay, so before they gave us what x was, or at least we had to check to see if that's what x was. But now we're figuring out what is x equal to, and then we're going to check our solution to see if we're correct. So instead of an x, I'm going to put 31 plus 62 equals 93. Then I'm going to actually do the math. Okay, I could do it off to the side. 62 plus 31, 2 plus 1 is 3, 6 plus 3 is 9, and I would get 93 equals 93. And I'm going to put a little check mark by it to show that I checked my work. Okay, so let's try this one over here. The next one says 81 equals 17 plus y. I want to get y by itself, so I've got to get rid of this 17. Okay, so to get rid of 17, I'm just going to subtract 17. That's also the inverse operation. So I need to subtract 17 from both sides of the equal sign because I want it to be balanced. 17 minus 17 is 0. I'm going to bring down my y and my equal sign, and I have to do 81 minus 17. So I need to ungroup here. 11 minus 7 is going to equal 4. 7 minus 1 is going to equal 6. So I got y equals 64. I'll put a box around it. Now I need to check. I need to solve my equation for y equals 64. So I'm going to write down 81 equals 17 plus 64. And I need to do 64 plus 17 is 11 is 81. So if I add that together, I'm going to get 81 equals 81. Checks out. I know I got my answer correct. Okay, and now sometimes kids, like I said before, they feel like, well, Mrs. Hamer, I just subtracted. Why do I need to add it together? And like I said, it's just that safety net saying, did I make a small mistake? We kind of saw that with our last test, our chapter 1 test, that we made little mistakes, and after I brought it up, you're like, oh, come on, how did I miss that? How did I forget to do that? So it's just that safety net to check to make sure that you did your math correct. All right, we have one word problem here. Tulsa, Oklahoma City, and Lawton are located in Oklahoma, as you can see on the map. Find the distance D, so we need to find this distance here between Oklahoma City and Tulsa. So here's what I see. I know how far it is from Lawton to Oklahoma City, and I know how far it is from Lawton all the way to Tulsa, but I need to find this missing piece. So I know that if I add 75 plus the distance D, I'm going to equal the total distance, which is 175 miles. Okay, and here's a thing I could think about too. I already know I'm studying addition equations, so I know that probably what I'm going to figure out is going to be an addition equation, so I can use that to check my equation to see if it matches what we're studying. Okay, so to get D all by itself on the equal sign, I need to subtract or get rid of this 75. So I'd subtract 75 from both sides. I would get 100 on the right side equals, this would cross out, bring down my D. So the distance is 100. Now don't forget your label. 100 miles is how far it is from Oklahoma City to Tulsa. Okay, so these are a little bit trickier. You have to first come up with your equation, then you have to solve it. Now, does it say check your answer? No, but could I check my answer? Yeah, of course I could. I could go back, I could say 75 plus 100 equals 175. I know that's 175 equals 175, check. Checked out. Okay, so that's all that I have for you today. Not too hard, but please make sure you're using those inverse operations to solve for your variable. I know that you could probably do some of it in your head, but please make sure that you show your work, just like how I'm showing you on here. So if you didn't write down the examples, then please go back and write a couple examples down so you have them for tomorrow. Thank you for watching, and I hope you have a great night.